Okay, so in this problem we're asked to find charge on each of the four capacitors. So, really the first thing I'm going to do is I'm going to recognize that C2 and C4, I know it looks like they're in parallel from the way they're drawn, because they look that way, but honestly, remember that for a series, capacitors arranged in series are connected by a single simple wire, even if it bends. So C2 and C4 are in series. So I can say that there's an equivalent capacitor there. I can draw like this. Where this is C1, and this is C3, and this is C24. And to find C24, since it's in series, I've got to do this. So C24 is 1.33 microfarads. Now, next thing I'm going to do is I'm going to combine these two capacitors because they are clearly in parallel, right? This wire has a certain potential and this wire has another potential. So the potential difference across both of them is the same. So I can write them as a single, simple capacitor like this. Where I have C1 and then this will be C234. Now for capacitors that are in parallel, I add the capacitances together like that. So that gives me 4.33 microfarads. And then finally, these two capacitors are in series with one another, so I can draw it like this. Where this is C total. Now C1 and C234 are in series, so I would write 1 over C total is 1 over C1 plus 1 over C234. So when I solve for C total, I get C total is 0.813 microfarads. Alright, so now of course the reason I did that is because, we have to find a capacitor somewhere in this mess. We have to find a capacitor where we know 2 out of 3 quantities. Finally, I have a capacitor where I know 2 out of 3 quantities, because the total potential is 24 volts. And so I can write Q total is equal to C total delta V total. And that's 19.5 microcoulombs. Alright, well now if the charge on this one is 19.5, then that means the charge on each one of these, they're in series, right? So these two guys have to have the same charge. So I can write that Q1 is equal to Q234, and that's also 19.5 microcoulombs. So there's Q1. Q1 is, if I round off to 2 sig figs, Q1 is 20 microcoulombs. Okay, let's continue then. Now let's look at capacitor C234 here. I know the charge on it, and so the voltage drop across 234 is Q over C. That's 4.5 volts. Right? It's Q over C is 19.5 divided by 4.33. Right? Q234 over C234 is 4.5 volts. Well, if the voltage drop across this sucker is 4.5 volts, then that means the voltage drop here and the voltage drop here is also 4.5 volts. So for Q3, that's equal to C3 delta V3. That's 3 microfarads times 4.5 volts. So that rounds to 14 microcoulombs. Okay, now we're done with Q3. Oh, but we need this capacitor C24 now. Right, so for capacitor C24, we have Q24 is let's see, it's C24 delta V24. So I'm using C24 and delta V24, which is 4.5. So that's 1.33 times 4.5, that's 6 microcoulombs. So if Q24, right, C24 represents C2 and C4 in series, and if the charge is 6, that means the charge on each of these is also 6. So Q2 equals Q4 equals 6 microcoulombs. Okay, I'm done.